Welcome back. Today we're gonna be reviewing. Okay, so we have about 15 problems to take care of. I hope we're gonna be having enough time for that. So let's start. The first problem. What am I looking for? Read it. Go ahead and read it and tell me what am I looking for. Well, I'm looking for how much after 5 years. And this is F5, right?
Yeah.
This is what? This is F5. And we're talking about a single sum of $10, right? The rate of return is 8%. And returns are promised semi-annually, right? So single sum of $10, R 8%, M is 2, and N is how much? N is 5, right? N is 5, right? So let's go ahead and solve that. Let's go ahead and solve that. So what am I going to be looking for here? I'm looking for, I'm looking for F5, and this is what? F5 is what? F5 is what in finance? It's C. It's what, C. F5, C in finance, right? C of what? C of what? We have 10 bucks, right? And those are a single sum, right? We have an R of 8%, right? We have an R of 8%, right? We have an M of 2 because semi-annual, right? Because of what? Because semi-annual, right? And we have N of 5 years, right? We have N of 5 years. And the answer is going to be what? And the answer is going to be what? Gentlemen?
Question.
Of course.
What do you mean by C? Compounding?
Compounding, yes. Compounding. C is compounding. Okay, so...
Because you have 5 years.
Right. Because we're solving for the future.
For the future?
Yeah, because I'm solving for the future. So I'm going to be compounding. I'm going to be going ahead of time. You got it? As opposed to back in time. You see that? Good. So... what are we going to be doing here? So this is going to be how much?
F5.
This is going to be 10 times what? 1 plus 8%, right? 8% over to the power of 2 times 5, right? And the answer is going to be how much? And the answer is going to be 14.8. Right? And the answer is going to be what,
14.8.
And the answer is going to be $14.8. I hope this is clear. Right?
Excuse me, the first, is it the formula for the
Compounding, exactly. Right, it is. It is. It is. It is the single sum, which is what did I do here? It is P0. It is what, P0, the single sum, times 1 plus R over M, right? To the power of M times N, right? Right? You got it? All right. I hope this is a sense maker. Okay. So let's go ahead and see the second problem. Let's go ahead and see the second problem. Okay. So quickies though, because we have 15 of them. We have 15 problems. So we're going to be racing against time today. And we're going to be working with time a lot because this is what finance is all about. It's all about time. It's all about time and R, right? It's the big question of P0, the big answer of future benefits, and the toolbox of T and R, right? Right? And the toolbox of T and R. I hope this is clear. And this is going to be our culture today throughout. Okay, so... are we done, guys, here? We're done? All right, let's go ahead and see the second problem. Let's go ahead and see the second problem. For the second problem, what am I looking for? The second problem here. What am I looking for in the second problem? Well, I'm looking for how much should you invest now in order to qualify for 14.8 after 5 years, right? So what am I asking you about? I'm not asking you about the future, right? I'm asking you about what? About now, which is what? Which is P0, which is what? Which is P0. So this is just the opposite of the first problem. This is what? This is the opposite of the first problem. In the first problem, we were given the $10, right? And we were solving for the 14.8, right? In the second problem, we have the opposite. We are given the 14.8 and we're going to be solving back for the $10. So how can we do it? Yeah, how can we do it? How can we do it? This is how. What am I solving for? P0. What am I solving for? I'm solving for what? I'm solving for P0, right? P0 is what? P0 is what? P0 is D, right? P0 is D. This is what finance is all about. P0 is D. P0 is D. Finance is all about discounting, right? Right? So finance is all about going back in time as opposed to going ahead of time, right? So P0 is D. D of what? D of what? D of 14.8. And this what? And this is a single sum, of course. Right? R of 8%. How much is M? 2 for M. How much is N? 5 years. All right. And the answer? And the answer? 14.8 times 1 plus 8% over 2 to the power of, well, I'm going back in time, right? I'm going back in time, and therefore the power is going to be negative. The power is going to be what? The power is going to be negative. So it's going to be to the power of, negative 2 times 5, and the answer is going to be $10, hands down. You don't have to do it. You don't have to do it. This problem is nothing but the opposite of the first problem, and I hope this is clear. You got it? You see that? This problem is the opposite of the first problem. If you want to go back to the first problem, get some intuition. What did I do here? If I were solving for 10, what should I do mathematically? What should I do? 10 is what? 10 is the 14.8 divided by this guy, right? Right? Which is 14.8 times this guy to the power of negative 2 times 5, right? You got it? You see that?
Yes, fine.
So this is nothing but, the first problem, we were given the $10 and we were solving for the 14.8, right? In the second problem, we are given the 14.8 and we were solving for, the $10. In the first problem, I was given now $10 and I was going ahead of time, 5 years, in order to get to the 14.8. In the second problem, I am promised 14.85 years from now, right? And I want to know how much should I set aside now, right? And how much should I set aside now in order to qualify for 14.85 years from now? I should set aside $10, and exactly $10. You got it? You see that? I hope this is clear. Good, thank you. Yes, sir. Negative 2 times 5. So what's the answer again? What's the answer? So P0 is what? P0 is always what? P0 is always going to be what? It's going to be Fn, bravo, times 1 plus R over M, bravo, to the power of? Negative, right. M times N, right? You got it? So this is how things are, right? And sorry, here. So R over M. I hope this is clear, okay? So are we done? Let's go ahead and see the third problem, okay? Let's go ahead and see the third problem. So the third problem. What are we going to be solving for? Read the problem. Read the problem. The third problem, what am I going to be solving for? Well, on the third problem here, in the third problem here, I'm solving for how much we should invest now, right? How much now? Well, what am I solving for? All right, I'm solving for the future, right?
Yes.
I'm solving for F5 still, right? I'm solving for F5, right? You're gonna be setting aside $10 now, but those $10 are not gonna be a single sum, because you're going to be setting aside $10 every 3 months. You're going to be setting aside $10 every quarter. So this is an annuity, right? If you set aside an annuity of $10, how much for 5 years at a rate of return of 8%, how much you're going to be having after 5 years? This is the question we're asking. So you're not going to be setting aside $10 now and that's it. No, you're going to be setting aside $10 every 3 months over 5 years. Over what, huh? Over 5 years. Good. So this is an annuity problem. How are we going to be thinking about it? Any idea? How are we going to be thinking about it? Well, let's see.
F5.
Right. So we're going to be solving for F5, right? We're going to be solving for F5, right? So what am I solving for again? It's F5, right? And what's F5 in finance? What's NEF in finance? It's C. It's what, huh? C. What's NEF in finance? C. What's P0 in finance? D. Please, okay? What's NEF in finance? C. Because it's all about the future, right? What about P0? It's all about D, right? Because we're going to be going back in time. We're going to be going back in time to the present, of course, given some future. So F5 is going to be what, huh? C. C of what? Well, instead of $10, right? But those are not single sum anymore, right? Those are an annuity because those are periodic, right? This much is periodic. This much is going to be set aside every 3 months, every quarter. So this is what we refer to as an annuity, right? Because what's an annuity? What's an annuity? What's an annuity? It's a periodic single sum. It's what, huh? It's a periodic single sum for some n. It's a periodic single sum for some n. So it's a single sum per m for some n. You got it? You got it? So it's a periodic single sum. Good. R is how much? 8% still. M is 4 because we're talking about quarters, right? We're talking about quarters. So M is 4 because how many quarters we have in a year?
4.
How many 3 months we have in a year?
4.
We have 4 3 months in a year, right? Right? We have 4 quarters in a year. Therefore, M is 4. What about N?
5.
N is 5. And how are we going to be answering to it? This is an annuity compounding, right? This is what? Huh? This is an annuity compounding. So how are we going to be solving? How are we going to be solving it? How are we going to be answering to it? So this is going to be what? Huh? This is going to be 10 times what? 10 times, huh?
1 plus
Right. 1 plus
8%
8%
divided by
over 4. Bravo. To the power of, huh? 4 times 5 minus 1 over, huh? 8%
Divide
over 4. Good. Bravo. And this is going to be how much? And this is going to be how much? And this is going to be how much? So this is how we in this world compound an annuity, right? This is an annuity compounding, right? This is an annuity compounding, right? If you're missing it here, consult the first week of classes or, okay, the first couple of weeks of classes. You should have it very clear. But we don't have time to go over the details here. I hope this is clear. So tell me, how much is it now? So this is how we compound an annuity. This is what, huh? This is how we compound an annuity. How much is it, Ahmed? Who I call Hamza? Ahmed, who I call Hamza. How much is it now?
242.97.
242.9. All right, great. 242.9 dollars. Good. Sounds correct. 242.9. Great. 242.9. $243 almost. All right. $243. Okay, I hope this is clear. Does it make any sense, Mansour?
That's okay.
Yeah? Good. So this is now an annuity, right? You know now why this problem is different from the first problem, right? Right? In the first problem, we were compounding a single sum, right? We were compounding a one-time amount, right? But in the third problem, what are we compounding? We're compounding an annuity. We're compounding $10 every 3 months over the course of 5 years, right? You got it? You see that? I hope this is clear. I hope you can see the difference between the first problem and the third problem. You got it? So in the first problem, we were compounding a single sum. We were compounding a one-time amount of $10. In the third problem, we are compounding $10 every 3 months over the course of 5 years. You got it? So I hope this is clear. All right, let's go ahead and see the fourth problem. And it's Ibrahim's problem. And Ibrahim's problem is not our problem. It is not your problem. It's his problem. All right, let's go ahead and see it. What am I asking you about here?
How much should invest now in all your
A problem well read is a problem half solved. Okay, so before you rush to the answer, take your time and read into the problem. Because when you read it correctly, you're almost done solving it. All right, so what am I asking you about here? What am I asking you about here? I'm asking you about now. Am I asking you about sometime in the future? Or am I possibly asking you about now? I'm asking you about now. And now is what in finance? P0. Great. Now is P0 in finance. Great. So this is how much I'm asking you about. I'm asking you about P0. All right. And given what? Given what? Given $10 every 3 months. Right? So in the third problem, given $10 every 3 months for 5 years. So in the third problem, we were compounding $10 every 3 months for 5 years. In this problem, we're going to be discounting $10 every 3 months for 5 years. You got it? I hope this is clear. All right, let's go ahead and solve it. So what should I do now? Okay, so what am I after? I'm after P0. I'm after what? Huh? P0. P0 is what in finance? It's D. Right. This is what finance is all about. There's nothing more to finance than that simple, beautiful, nice-looking equation. P0 is D. P0 is D. Finance is about valuation, right? Finance is about pricing. And pricing is all about discounting, right? And what are we going to be discounting? We discount future benefits. We discount future promises, right? All right. So what am I discounting in that particular problem?
10%.
I'm discounting what? Huh? $10. And what are those, Mansour? $10. What are those? Are they a single sum? Are they a single sum? No, it is not a single sum. Why? Because it's every period, every quarter. So it's an annuity. It's what? Huh?
Annuity.
Okay, it's an annuity. Bravo, Mansour. So R is how much? Huh? R is 8%. Thank you, Abdullah. M is how much?
4.
M is 4 because it's quarterly, right? It's quarters, right? It's quarterly, and this is why M is 4. All right. And N is how much?
5.
N is 5. Good. Good job. So let's continue. What should I have here?
P0 times.
So this is going to be what? Huh? No, I'm solving for P0, so it's going to be 10 times.
10 times. That's
10 times what?
which is yeah, P.
Ahmed, tell me what, huh?
1 minus
1 minus, bravo.
1 plus
1 plus, good.
8%.
8%, yes sir. Over
Over 4
to the power of
minus
negative 4.
4
Minus is an operation, negative is a sign. Are you after the operation or the sign?
and a sign.
The sign, and therefore it's negative. Over what?
8.
Over 8%.
Over.
Over 4. Bravo. And the answer is going to be how much? And the answer is going to be how much? So how much you should invest now to qualify for $10 every quarter over the course of 5 years at a rate of return of 8%? This is my question. You got it? Huh? How much you should, what am I answering to now? I'm answering to that problem. How much you should set aside now, how much you should invest now in order to qualify for $10 every 3 months for 5 years at a rate of return of 8%. And how much is it, Ahmed?
163.5.
$163.5. Good. $163.5, of course. $163.5. Okay? $163.5. $163.50. I hope this is clear. You got it? So in the first problem, what was I solving for? In the first problem, what was I solving for? I was solving for F5, but I was compounding a single sum, right? I was compounding what? A single sum. In the second problem, I was solving for P0 by discounting a single sum, right? In the third problem, I was solving for F5 by compounding an annuity, right? And in the fourth problem, what did I do? I was solving for P0 by discounting an annuity. You got it? Right? By discounting what? An annuity. You see what I'm driving at? Huh? Good. All right. Let's go ahead and see the next problem. And whose problem is it? Oh, it's Abdullah's problem. Oh, looky here. It's Abdullah Sruji's problem. So it is definitely not my problem. All right. So how can we think of it? How can we think of it? Read the problem carefully. It's your dad's problem. So read the problem carefully.
It's also
What am I solving for, Mansoor?
present value.
Good. I'm solving for now, right? I'm solving for P0. Good. So I'm solving for what, huh? I'm solving for P0 because, am I solving for P0 here? No. I'm not solving for P0. Read the problem carefully. I'm not solving for P0. I'm solving for how much should I set aside every period. I'm solving for how much should I set aside every 3 months. I'm solving for the annuity amount. I'm not solving for P0. I'm not solving for F5. I'm solving for the annuity amount. I'm solving for what? Huh? I'm solving for the annuity amount, right? I'm solving for what? Huh? For the annuity amount. Given what? Given F5. Given what? Huh?
F5.
Given F5, right? So given F5, right? Given F5, how much is the missing annuity amount? So let's see the setup for that problem. This is an interesting problem. Let's go ahead and see the setup for it. But read it carefully first. Read it carefully first. So I'm asking for what? Huh? I'm asking for the annuity amount. I'm asking for how much you should set aside every 3 months in order to qualify for $243 after 5 years. And this is nothing but solving for the annuity amount. All right, let's see how. So what am I having now? What am I provided with? What am I provided with?
F5.
I'm provided with F5, right? Right?
Yes.
And F5 is how much?
242.
It is 242.9, right? But F5 is what in finance? It's C. Bravo. Good. So F5 is what in finance? It is C. C of what? C of how much? I don't know, right? I don't know it because this much is missing now, right? This much is missing now. So I don't know how much, right? But I know what it is, right? I don't know how much, but I know very well what it is, right? And what is it? It's an annuity. As opposed to a single sum, as opposed to a perpetuity, it's an annuity, right? So I know what is it, but I don't know how much, right? Right? But there's a way to find out how much. Okay, let's see. So it's an annuity. So what's missing is an annuity. R is how much? 8%.
4.
M is what? M is 4. N is 5 years. N is what, huh? 5 years. And the answer? So we're going to be having 242.9 equals what? Equals what's missing, right? Equals what, huh? Equals what's missing, which I don't know how much, right? I'm about to find out. What's missing times what? What's missing times what?
1 minus.
No, it's 1 plus.
1 plus
1 plus
8%
8%
by 4.
Overall.
over 4 to the power of 4
Multiply.
times 5 minus 1 over
8%
8%
Over 4.
over 4. And what's missing is going to be how much?
10.
Of course. Thank you. And so my question mark is going to be how much? It's going to be nothing but the $10. Why? Because this is the exact opposite of the previous problem. You got it? This is the exact opposite of right, the third problem, I guess. Right, good. So this is the exact opposite of the third problem. Alright, well, here, what was going on? Let's just like pause for a couple of seconds and comment. What was going on here? So you were given the F5, right? And what are we solving for? We're solving for the missing annuity. We're solving for what, huh? We're solving for the missing annuity. But in the third problem, we were given the annuity, right? And we were solving for what, huh? We were solving for the F5, right? So given the 10, F5 is going to be how much? 242. In that problem, the fifth problem, given an F5 of 242, the missing annuity is how much? Is going to be 10. So in the fifth problem, we were given the 242, and we were solving back for the 10. But in the third problem, we were given the 10, and we were solving ahead for the 242. I hope this is clear, right? The fifth problem is nothing but the exact opposite of the third problem.
What is missing is we can call it as P0.
No, what's missing here? What's missing here was F5. In the third problem, what was missing is a F5. But in the fifth problem, what's missing is the annuity amount. See that question mark? This is not P0. Of course not P0. This is the annuity amount. This is the amount set aside every 3 months. P0 is a one-time amount now, right? F5 is a one-time amount 5 years from now. What's missing is a periodic amount. You got it? You see that? See the difference here? P0 is a one-time amount now. F5 is a one-time amount 5 years from now. What's missing here is a periodic amount. Is an amount every 3 months for 5 years. You got it? So what's missing here is a periodic amount. It is not a one-time amount. What's missing in the fifth problem is not a one-time amount. It's a periodic amount, which we refer to as an annuity, right? Which we refer to as what? An annuity.
So you just divide this value.
Of course, we just solve for that question mark, and the answer is going to be 10, right? Just solve for that question mark, and the answer is going to be what? And the answer is going to be 10. Let's go ahead and see the sixth problem. Are we done here, guys? Any questions? Any questions? Abdullah, any questions? Any questions? Okay, so let's go ahead and see the sixth problem, okay? Whose problem? Fahad's problem. Fahad's not here. Oh my God, this is great. So we should drop him out, too. Thank you. Left in my spirits. All right, guys, so it's Fahad's problem. And what are we going to be solving here for? Look at it. What are we going to be solving here for? How much should Fahad invest now? What's the now finance? P0. If your answer was P0, you must be on the right track. Good job. So we're solving for P0 in order to qualify for what? For $10 per year.
Forever.
Oh yeah, that's a key word here. Yeah. So how much you should invest now in order to qualify for $10 a year for infinity, right? And this is what now? This is a perpetuity, right? Because what's a perpetuity?
It's an animal.
It's a periodic amount for infinity. It's a periodic amount for infinity. So this is a perpetuity case. This is what? This is a perpetuity case. Good. How are we going to be answering to it? All right, let's see how. What am I solving for? Of course, P0. If you don't trust me, you can ask Ahmed, who I call Hamza. So we're solving for P0, definitely. P0 is what in finance?
P10.
Huh? P0 is D. Ahmed, come on.
He's answering.
P0 is D. P0 is D. P0 is what? What finance is all about? P0 is D. What finance is all about? So this is what finance is all about. The rest of finance is nothing but applications. You got it? So P0 is D. This much totally, without any loss, defines the discipline of finance. The rest is nothing but an application. You got it? So I hope this is clear. I hope the world is making sure this is clear. So P0 equals D of what?
$10.
It's $10, right? And what are those? Those are not a single sum. Those are not an annuity. Those are, bravo, Mansour. Those are a perpetuity. Those are a perpetuity, right? R is how much?
8.
R is how much?
8.
R is 8%. M is how much?
1.
It's 1. Why? Because it's $10 a year, right? It's $10 per year, and therefore M is what? M is 1. Once a year. Once a year. So a year is a period. A year is what? A year is a period. Once a year, this means that like a year is a period, right? Good. And N,
12.
N is infinity, right? And can we write down N equals infinity? No, this is not mathematically correct, because we can never reach infinity, but we can always come closer. So the way we do it mathematically, we write down N approaches infinity. N what? Approaches infinity. You got it? So we cannot write down N equals to infinity because nothing equals infinity, but infinity, of course. Okay? Nothing equals infinity but infinity, right? So infinity is sort of like a concept that is not reached, but we can always come closer and closer, right? Mm-hmm. Right? Good. I hope this is clear. So the answer is going to be how much?
10.
The answer is going to be how much?
10.
This is going to be 10 over 8% over M, which is over 1, which is going to be what?
120.
10 over 10% over 1, which is 10 over 10%. And the answer is going to be, of course, the very handsome $125, right? Right? You got it? So this is how we do a perpetuity. This is how we do what? This is how we do a perpetuity, right? So it's a sense maker to discount a perpetuity, right? It doesn't make any sense to compound a perpetuity. Why? So we can go ahead and discount a perpetuity. It doesn't make any sense to compound a perpetuity. Why? Because an infinity of dollars cannot be premised. Right?
So
It is not any sensible. It is not any sensible to promise an infinity of dollars, and therefore it doesn't make any sense to compound an annuity, a perpetuity. It doesn't make any sense to compound a perpetuity, right? So a perpetuity is only good for discounting, right? It cannot be compounded. It doesn't make sense for us to compound a perpetuity because eventually we're going to be getting to an infinity of dollars, which is not a sense maker, right? Which doesn't make, oh yeah, of course, it doesn't make any sense. I hope this is clear.
That's when I invest now 100.
No, yeah, you invest now.
Every year I will
Good.
for
You set aside now.
forever.
Yeah, and we're real about it. We're good for it. So this infinity, this isn't. We're talking about an infinity of time. So you set aside now $125, and you're going to be entitled to $10 every year for infinity. Yeah, for infinity. So after you're not more anymore, your children are going to be entitled to $10 per year. And after your children are not more anymore, their children are going to be, and so on. We're talking about infinity here. You got it? And so what you gotta do at a rate of return of 8% to be entitled to $10 per year for infinity is simply to set aside $125 now, which is not much. But well, again, investment is beautiful because it's so. You never know.
We honest, after taking this class, it became.
Interesting. Thank you.
Before that, frankly,
Who's Barat?
not like.
You're Barat. Okay, good. Alright, Barat. So, what are we solving here? The seventh problem. It's your problem now. It is not Majid's problem, for example. So, yeah, that's the nice gentleman here to the back. So tell us, Barat, what are we going to be solving for?
If one,
What are we going to be solving for? Any idea, Mansoor? We're not going to be solving for anything. We are proving here, right? We're going to be showing that, right? But we're going to be solving for something, right? We're going to be solving for something. So we're going to be solving for F1. Bravo, Abdullah. We're going to be solving for F1 because our question is about 1 year, right? It's about after 1 year, and therefore the answer has to be what has to do with F1, right? But the single sum is going to be $1. The rate of return is going to be 100%, and returns are going to be what? Are going to be continuous, right? So we're not talking about annual returns. We're not talking about semi-annual returns. We're not talking about monthly returns. We're not talking about quarterly returns. We're not talking about daily returns or hourly returns even. We're talking about continuous returns, right? So how can we possibly make sense of that problem? Well, let's see. But read it first. Read it first carefully. And tell me what are you going to be having in the stock. So read it first. And let's see. Good. So this is how I think of it. It's a nice problem. So this is how I think of it. What am I solving for? I'm solving for F1, right? F1 is what in finance? Any F is what in finance? Mansoor?
C.
C. Thank you. Thank you. Great. C of what? C of what? It's a buck. It's $1, right? It's $1, right? And what is it? It's a single sum, right? It's what, Single sum. R is how much? 100%. Great. R is how much, 100%. M is going to be how much?
Why do we say single sum?
Because it's a one-time amount. Okay? It's a one-time amount. It is not periodic, right? It's a one-time amount. So M is going to be how much? We're talking about continuous returns. So M is going to be what? Is going to be approaching infinity, right? So M is going to be approaching what, M is going to be what, Approaching infinity. What about N? N is a year because we're solving for F1. So N is what? N is 1. All right, and the answer? And tell me now, whenever we have infinity, whenever we have returns promised for infinity, right? Whenever we have returns promised for infinity, what are we going to be having mathematically?
Infinity.
Well, mathematically, we're going to be having what? We're going to be having E. We're going to be having what, We're going to be having E, right? Right? We talked about it before, right? We talked about it before, right?
No.
We're going to be having, no, we did. We did. We're going to be having E. We're going to be having what, E. And the answer is going to be, what? And the answer is going to be what?
E infinity.
Well, in general, whenever returns are promised continuously, Fn is going to be what? Fn is going to be what? Fn is going to be the dollar amount. Fn is going to be what, The dollar amount times what? Times E to the power of Rn. To the power of what, Rn, right? Right? Now, what we have, how much is the dollar amount? 1 times E to the power of to the power of r, which is what? Which is 100%, which is 1, right? Times n, and n is what? N is 1, so it's going to be 1 times 1, which is going to be what? Which is going to be e dollars, which is going to be what, huh? 1 times e to the power of 1 is what? Is e, and e times 1 is what? Is e. So if you set aside now $1, right? Right? If you set aside now $1 for continuous returns, after a year, you're going to be having exactly e dollars. You're going to be having exactly what? You're going to be having exactly e dollars. How much is e? 2.71828. You got it? Something like that. You got it? 2.71828. You got it? It's a number in mathematics. It's 2.71828. It's an irrational number, right? 2.71828, which is e, right? 2.71828, almost. 2.71828. We call it e. We call 2.71828 e in mathematics, right? So if you set aside now $1, if you set aside now $1 for continuous returns, after a year, you're going to be going home exactly with $2.71828. You got it? You're going to be going home with exactly e dollars, right? And I hope this is clear. And we're done. We have satisfied the problem. We have now satisfied that if you set aside $1 now for continuous returns, after 1 year, you're going to be exactly having e dollars. Okay? All right. Let's go ahead and see the next problem. Okay, so Mansour's problem. What are we going to be solving for here? What are we going to be solving for here? We have 4 streams, right? We have 4 assets. We have what, huh? We have 4 assets, right? We have 4 streams. And for each and every asset, we're going to be what? For the first part, what are we going to be solving for? We're going to be solving for F5. For the second part, we're going to be solving for P0. You got it? You see that? So we're going to be solving for F5 and P0 as far as each one of those 4 assets is concerned. All right. So let's go ahead and see how. Let's consider the first asset, Mansour 1, the first asset, the first Mansour. All right. So the first Mansour. So let's see. The first Mansour. So for the first Mansour, P0 is going to be what?
100.
What's P0 in finance?
D.
It's D. P0 is what in finance, huh? It's D. D of what? D of what?
First year, 100.
We have 100, right? For the first year, right?
Yeah.
Then we have
200 or 100.
Then we have 200
Year 2. 300
for the second year, 300
and 300.
for the third year, 300 for the fourth year, and
Fifth year, 300.
so 200 for the second year. How much is it for the third year?
It's 100, and then
200.
and then the third 200.
The third is 200.
Yes.
All right. So the third,
It's 200.
okay,
200, 300.
300, and for the fifth year,
300 as well.
okay. And R is what?
10%.
R is 10%. M is what?
And it's
Our annual one.
Tommy here.
1.
We're talking about annual returns. So M is what? M is 1, and N is how much? N is 5, of course. N is what, huh? N is 5. Okay, so how are we going to be solving it? So first we have to do what?
So 100.
Nine.
So we have to discount the 100 a year from now, right? We have to discount 100 a year from now. So what are we going to be doing?
100
What are we going to be doing? This is going to be what?
100
This is going to be 100
times
times
1
1
plus
plus 10%, which is what? Which is what? What's 1 plus 10%? How much is 1 plus 10%? It's 1.1, right?
okay
To the power of,
negative
Negative what?
1
Bravo, negative 1. Bravo, Brahim, good. Plus. How are we going to be discounting the $200 2 years ahead?
so plus 200 times
How are we? Of course. Plus what,
200 times
200 times what?
1.1
All right, to the power of?
negative 2
Yes, sir. Super duper. Plus.
the 200 again
All right, the 200 again. Times 1.1 to the power of?
Negative 3.
Negative 3, of course. Plus
300
300 again.
times
Times
1.1
1.1 to the power of?
negative 4
Negative 4. Plus
the same but with negative 5
300 again. Times 1.1 to the power of? Negative 5. And the answer? And the answer is going to be how much, Ahmed? And the answer is going to be how much? Any questions? Huh? I solved the second part first because the first part was asking actually about F5. The second part was asking about P0. So I started with the second part. No problem. Forgive me for the inconsistency. Okay? So now we did the P0. Let's go ahead and do the F5. But tell me how much first. How much, Ahmed?
who you call Hamza
Who I call Hamza, of course. Well, actually now I called him Osama. I don't know. Very, very confusing. Confusing as they come. Okay, so how much, Ahmed? You're not participating, Alauddin. I'm marking you down. Participate.
8.48.
Aladi
Alauddin is not participating. How much is it, Ahmed?
848.
848. All right. 848. 848. 848, huh? 0.3.
0.20.
All right, no problem. So, sorry here. Okay, so 848.13. All right, good. Let's go ahead and solve for P. Let's go ahead and solve for F5. Let's go ahead and solve for F5. Now, this is a, we're still at Mansour 1, right? But this is this is the second part.
the 14%.
Yeah, let's go ahead and satisfy the first part. What did I do here? Just like I'm sorry, I'm a mess. I should have discounted with the 14%, right?
Not 10?
I'm sorry, yeah, 10% was for compounding, was for F5, right?
It's our problem.
But it's the same, you know, the same concept. No problem. The same concept. Let's go ahead and solve for F5. Let's go ahead and solve M1 for F5. So how are we going to be doing that?
So are we going to use the 14% now?
For P0, use the 14% instead of 10%. Okay. So for P0, use the 14. Right. For P0, use go ahead and use the 14% instead of the 10%. Okay. For P0, use the 14%. But for F5, we're going to be using the 10%. All right. Let's go ahead and do it.
So,
Change the percentage.
Just change that 10% to 14% and solve accordingly.
yeah,
Okay, I'm sorry.
27, 10.
You should have told me. You should have. Okay, so let's go ahead and now and see and solve for f5.
So it will be Mansour 1 as well?
Yeah, of course. So,
So we have it already.
but this is p0. Let's go ahead and do f5. So, what are we going to be solving for here? We're going to be solving for, f5. F5 is what? F5 is what in finance? It's C. C of what? We have $100 after 1 year, 200 after 2 years, 200 after 3 years, 300 after 4 years, and 300 again after 5 years, right? R is going to be how much now? 10%. Good. R is going to be 10%. M is going to be how much? It's going to be 1 because we're talking about annual, right? And N is going to be how much?
14 or 10?
10%. 10%. F5 is 10%.
So the P0 is
I solved the P0 first. I solved the second part first,
we mistake.
right? Okay, and N is going to be how much, guys?
5.
N is 5, of course. N is 5. So tell me now, what should I do?
100.
So this is going to be how much?
100 times
All right, 100 times,
1 plus 10%,
which is 1.1 to the power of?
4.
Bravo, good. You see the difference here? You see why is it 4?
Because it's in 4 years.
Right. Because we're going to be bouncing 100 a year from now to 5 years from now. So how many years we're going to be going? We're going to be going 4 years. We're going to be going what, 4 years. And since each year is a period, we're going to be going in essence 4 periods. So to the power of what, The power of 4. Plus.
200
Plus what, 200 times 1.1 to the power of?
3.
To the power of how much, Ibrahim? 3, of course. Right? Plus.
200.
Plus 200 again. Times 1.1 to the power of? To the power of 2, right? Plus 300 times 1.1 to the power of? To the power of 1. To the power of what, To the power of what, To the power of 1, right? Right? Plus 300. Why? Because it's going to be what?
0.
It's going to be 300. Bravo, Brahim. Thank you so much. Because it's going to be 300 times 1.1 to the power of?
0.
To the power of 0, which is 1. And 1 times 300 is what? Is 1. And the answer is going to be? The answer is going to be how much, Ahmed?
1,284.
The answer is going to be what? 1284?
1,284.
All right,
9.61.
1284. 1284.
161.
1284, 16.16?
Yes.
161.
61.
61, all right, no problem. So 1284.61. I hope this is clear. You guys have questions so far? Things make sense now, Mansour?
اللي قبل دكتور النتيجة طلعت عندي غير بس هذه صح. هذه تصير.
We need to check. Again, we're going to use 14% instead of 10%.
Okay, this is great. So, any questions so far? All right, let's go ahead and see the next problem. Can you do like Mansour 2 and Mansour 3 and
Yeah, it's the same idea.
the same idea, right?
We have to pay the same question in the midterm. We have to answer all these answers. 2 hours, 3 hours.
4 Mansours. So there's not only 1 Mansour, it's 4 Mansours. Well, you have, well, the way I look at it, I can test your smarts, or I can test your ability to perform under time pressure. I'm not going to be testing your smarts. I'm not. So I'm not going to be playing games. But what I'm going to be testing you, based upon is your ability to perform under time pressure. I'm giving you a mission you can accomplish. So I can give you my strategy. You go home and try to answer all those questions under a time pressure of 2 hours, right? And the first time it is going to be taking you perhaps more than 2 hours. Then you do it again until you satisfy your mission, until you accomplish the objective. So I'm giving you something to do. I'm giving you something to do, which you can do.
It'll be a 2 hours exam?
It's going to be a 2 hours test, of course. Yeah, mostly. So yeah, so definitely you're going to be seeing the 4 Mansours. If this is what you're asking me.
Solve it into
Well, if it's the same idea.
Of course, you solve it for P0 and F5.
yeah, 1, 2, 3, 4.
You solve it for P0 and F5, of course. Of course. But I'm telling you about it ahead of time. So what should I do now? No, now we're not talking.
No, I think it's enough to solve one.
I want you to exercise. So do the 4.
I think 2 problems of myself. 4 answers.
All right. Let's go ahead and see the 9th problem. What am I asking you about here? In the 9th problem.
Can we take break? After 5 minutes. After the question. It'll be 5.
Are you tired? You're not doing anything. You're just sitting here and you shouldn't be tired at all. What's up, Majid? What's up? Huh? What's up? You shouldn't be tired. So the 9th problem, what should we do there? So the 9th problem, what should we do here? What are we going to be solving for?
F.
Well, we have 2 plans. And we're going to be going for the better plan. So which plan are we going to be going for? We have to find out about. And what are we going to be solving for? We're going to be solving for,
F10.
We're going to be solving for F10, exactly. We're asking a question about the future, right? We're not asking about F0. We're not asking about P0. We're actually asking about F10. Okay, so you're going to be going for the plan that promises you nicer after 10 years. You got it? So you're going to be going for the plan, whichever plan that promises you nicer after 10 years. So what are we going to be solving for is nothing but F10. Is nothing but F10. Let's go ahead and do it. So let's go ahead and do it. So F10. Okay, so tell me now for A1, Alauddin 1, F10 is going to be what?
Equals C.
F10 is what in finance?
C.
It's C. Bravo. C of what, Mansour?
C, 500.
C of what? 500.
500.
500.
Annuity, isn't it?
Of course.
Isn't it?
Oh, you got it. You got you. Wow, you're on the top of it. Of course. It's an annuity. Why? Because it's semi-annual deposit. It's a periodic amount. It's an amount every half a year, right? It's an amount every what? Every half a year. Half a year is a period, and therefore it's an amount every period, hence periodic. And therefore annuity. Therefore what? Therefore annuity. So $500, and this is an annuity, of course. Tell me about R. How much is R?
7%.
R 7%. M?
2.
M is 2 because we're talking semi-annual, right? We're talking what? We're talking semi-annual. We're talking about semi-annual things, right?
10.
And N is 10. Bravo. So now solve it. Now solve it.
500
It's going to be 500.
times.
500, huh? times what?
1. No, 1.
Of course 1. 1 plus,
7%
of course.
over 2.
Yes, sir. To the power of 2 times 10. Bravo, Abdullah. Minus
1.
over
7%.
7% over 2.
Yes.
Thank you. Thank you so much. 7% over 2. And the answer is going to be how much? And the answer is going to be how much, Hamad? Who I call Hazem.
حازم وحمزة ومصطفى عصمي.
How much is it? How much is it, Hamad? F10? This gentleman here is a highly decorated manager on campus. So you gotta get an appointment before you see him.
1 4
Huh?
1 4 138.
Good. 14, 138, right? It's gonna be 14, huh?
138.
138.
0.84.
Point what?
84.
Okay. Good. Good job. Good job. So let's go ahead and see the and see A2 and see Aladdin 2, right? Plan 2. Let's go ahead and see. And we're gonna be going for the plan which promises nicer after 10 years, right? Right? So let's go ahead and see now A2. Let's go ahead and see A2. So A2 is going to be how much?
7.5%.
Let's see now. So A2, what we have here? A2, what am I solving for here, guys, again? I'm solving for F10, right? F10 is what in finance? Majid?
C.
It's C. C of what? C of a grand, right? $1,000. What is it? It's an annuity, of course. It's what, huh? It's an annuity. Why? Because it's $1,000 every year. A year is a period. You see that? It's $1,000 every year. Again, right? It's $1,000 every year. A year is a period, right? So it's $1,000 and it's an annuity. And it's what, huh? And it's an annuity. Please, good.
So that's the same question, isn't it?
A2, but the second plan, the other plan, the other plan. So Tommy, now R is how much?
7.5.
Good. 7.5%. M is how much?
1.
M is 1 because we're talking about annual returns, right? And N is how much?
10.
Of course 10. And the answer?
1,000.
And the answer? A grand times. Times what? 1 plus 7.5%. Bravo, Mansour. Over 1, right? To the power of, huh? 1 times 10. 1 times, huh?
10.
Minus what, huh?
1.
Over
7.5.
7.5% over 1. Good. And the answer? And the answer is going to be how much, Hamza? Huh? Aladdin, participate. Otherwise, I'm going to be marking you down. Too fast, you wouldn't believe it.
It's his problem.
It's your problem, true. How much is it?
14.
14. 14 what?
14.
Bara? 14 what? 14?
1 4
14, 1, 4,
1 4 7
7.
0 9.
Okay, good. So it's going to be 14, 147. 14, 147. Now, which plan is nicer? Which plan you're going to be going for? Which plan you're going to be signing up for? Are you going to be signing up for this plan
Yeah.
Yes.
or for that plan?
No, the second.
You're going to be signing up for the second plan. Why? Because it promises you nicer after 5 years, right? So if you are promised $1,000 a year, right? Annual returns, right? At a rate of return of 7.5%, right? For 10 years, right? You're going to be promised 14, 140, 147 after 10 years, right? But if you were promised But if you were promised $500 every half a year, right? Semi-annual returns at a rate of return of 7% for 10 years, you are going to be promised $14,138 after 10 years, right? Now, which plan is nicer? Of course, the second plan is nicer. Why? Because it promises you more after 10 years. You got it? You got it? You see what I'm driving at?
Yeah.
Good. So this program here, the annual $1,000 rate of return 7.5% is going to be nicer than the semi-annual $500 rate of return 7%.
So the difference
You got it?
is almost about the 7.5%.
The difference is always about, well, the difference of finance is not about R by itself or time by itself. Finance is all about both, right? So you cannot consider R, you cannot build a finance argument just based on R or just based on T. A finance argument has to have both R and T. You got it? You see what I'm driving at?
Yeah.
Finance is all about the toolbox of T and R. So you have to have both, right? Any financial statement, any sound financial statement has to entertain some kind of information about both R and T, right? About both R and T. I hope this is clear. Okay, so we're gonna be doing now the 10th problem. What are we going to be solving for? The 10th problem. This is a smart problem.
Looking for
Same question.
Good. Bravo, Mansoor. In the 10th problem, we are going to be looking for R. And we're going to be learning a very important lesson in finance. We're going to be learning here a very, very important lesson in finance. Because P0 is unique, right? P0 is unique, right? Time 0 is unique. Now is unique, right? But the future is not, right? The future can be anything, right? When we're speaking of the future in finance, we're using Fn, right? And N can be anything. Can be 1, can be 2, can be 10, can be 5, can be a zillion, right? It can be anything. So unlike P0, the future is not unique. Unlike P0, the future is not unique. P0 is unique. The present is unique. Now is unique. And this is the lesson underlying that very smart problem. So let's go ahead and see what the problem is asking us to do. And we're asking here about the R that is going to be making you indifferent between receiving $25 after 6 years and $50 after 12 years. So what am I going to be solving for here? I'm going to be I'm asking you about indifference, right? So I'm asking you about the key to answering the indifference is to think of what's unique. Is to think of what's unique. And what's unique in finance? P0. What's unique in finance? P0. So we're going to be solving for what? P0. Why? Because our question is about some kind of indifference. Is about what? Is about some kind of indifference. Is about what? Some kind of indifference. So just because we're asking a question about some kind of indifference, right? Our logic has to be directed toward what's unique. Our logic has to be directed toward what's unique. Now what's unique in finance is P0. Now let's go ahead and solve for P0. So let's see how. P0 is unique in finance, right? Mm-hmm. So if you discount the $25, 6 years from now, it's exactly as if you are discounting the $50 12 years from now. Either way, you're going to be going back to P0, right? And that's a very important lesson in finance, right? Right? No matter what you're discounting, right? No matter what you're discounting, and no matter when, you're going to be always going back to, you're going to be always going back to the one and only P0. Right? The always unique P0. Again, let me repeat it. No matter how much you're going to be discounting and when, no matter how much you're going to be discounting or when, you're going to be always going back to the one and only P0. You're going to be always going back to what? To the one and only P0, to the unique P0. No wonder finance is all about P0. No wonder finance is all about P0. This much is unique. Good. P0 is going to be how much? It's going to be D of?
25 a single sum.
25. This is what? Single sum. R is going to be how much?
R, we don't know.
R is missing, great. We're going to be solving for it.
1.
1, of course, 6, right? 6 years. Which is what?
Which is 25.
Which is again what? Which is again what? Which is again discounting. Which is again what? Huh? Which is the same as discounting $50 single sum, right?
And then
R is missing again, right?
1,
M is 1, and 4, huh?
12.
12 years. Now we can solve for R. Now we can solve for what, huh? Now we can solve for R. You see what I'm driving at? This is a very important lesson of finance. A very, very important lesson of finance. No matter how much you're discounting or when, you're going to be always going back to the one and only P0. You got it? You're always going to be going back to what, huh? To the one and only P0. You got it? No matter how much you're discounting or when, no matter how much you're discounting or when, you're going to always be going back to the one and only P0, the one and only P0, the unique P0. This is a very important lesson in finance. A very, very important lesson in finance. So how much now? So let's go ahead and solve the first. The first is going to be what?
25
The first is going to be what, huh?
25.
25 times 1 plus R to the power of
6.
negative 6. Because we're discounting, Ibrahim, it's negative. Which is what, again? Let's go ahead and now discount the second program.
It's 50
This is going to be 50 times
1 plus R.
1 plus R to the power of negative 12. And now we can solve for R, right? We have an equation and a single unknown, and mathematics tells us that that single unknown can be solved for, right? So we can go ahead and solve for R now. How can we do it?
So 1 plus R.
So the 25 is going to be flying off with the 50, leaving us with 2 here. So we're going to be having 2 here, and this is going to be 1 plus R to the power of 6, right? And so R is going to be what? And so R is going to be 2 to the power of 1/6, right? Minus 1. It's going to be 2 to the power of 1/6. Sorry, here, let me clean it up for you. It's going to be 2. It's going to be 2 to the power of 1/6 minus 1, right? And the answer is going to be. And the answer is going to be.
What, 2?
R is going to be 2 to the power of 1/6 minus 1. It's going to be the 6th root of R, of 2, I'm sorry. R is going to be the 6th root of 2 minus 1. And the answer is going to be how much? 12.25. Thank you so much. And R is going to be 12. Write it down here. 12.25%. So R is going to be 12.25%. I hope this is clear. So R is going to be 12.25%. Yes, sir.
The very last steps, the right?
Yeah.
After like you, right? After equal to.
Right. I multiplied everybody by 1 plus R to the power of positive 12, right? If you do that, you're going to be having 2 here, nice and clean. And left-hand side is going to be boiling down to 1 plus R to the power of 6. Because 1 plus R to the power of negative 6 times 1 plus R to the power of 12 is going to be unite the bases, right? Which is 1 plus R to the power of 12 minus 6, which is going to be 1 plus R to the power of 6, right? Now you can go ahead and take the 6th root of the entire equation, right? When you do that, you're going to be getting rid of that 6 here, and you're going to be raising 2 to the power of 1/6. Over the left-hand side, you're going to be having 1 plus R. Over the right-hand side, you're going to be having 2 to the power of 1/6. And now we can solve for R, which is going to be 2 to the power of 1/6 minus 1, which is going to be 12.24%. You got it? You can double check the mathematics at home. This is elementary. So you can double check the mathematics at home, okay? Okay, let's go ahead and see the 11th problem.
Yes.
The 11th problem. What? For a Z, right? Yazid. Okay, I have no idea. Alright, he disappeared. He's infinity. Okay, good. So the 11th problem. Do you have any questions here? All right. Let's go ahead and see the 11th problem. This is a nice problem. We did it before. Let's go ahead and do it again. But read it first.
Oh, the bond.
Yeah, what am I solving for here? I'm solving for R, right? Again. I'm solving for, I'm solving for R, right? So finance is all about T and R, and it's always safe in finance to think in terms of a timeline. To think in terms of what, To think in terms of a timeline. So let's go ahead and see a timeline for this problem. Let's go ahead and see a timeline for that problem. Because I'm asking you about earn how much, right? So earn how much? Earn how much? This is earn how much return. Earn how much yield, right? Right? This is what the problem is about. This bond will earn how much? It's a question about R, right? Of course, it's a question about R. So this bond is going to be earning how much? Of course, this is definitely a question about R. So how are we going to be going about it? How are we going to be going about it? Think about it.
F3.
Okay, well, let's go ahead and see a timeline for it. Let's go ahead and see a timeline for it. So the 11th problem, what are we going to be solving for? It's always safe in finance to think in terms of a timeline, right? Let's go ahead and conceptualize a timeline for that problem. Let's see what we have. Okay, so let's go ahead and see a timeline here. Okay, here we go. So the timeline, how many years? 3 years, right? Right? But how many periods? Well, this is implicit, right? Because we know that real world bonds pay semi-annual coupons, right? And have a par value of $1,000, right? So we know this much, right? We know that real world bonds promise semi-annual coupons, and pay a par value of $1,000 at maturity. So we know this much, right? So we're going to be working semi-annually. Speaking of 3 years, that'd be 6 periods. So this is my first period, my second period, third period, fourth period, fifth period, and sixth period. So FMV is how much? FMV is how much?
900.
It's 951, right? 0.9. It's 951.9. This bond promises you how much for the first period? So this bond promises you how much coupon after half a year? It promises you $25 coupon, right? Because the coupon rate is 5%, it is going to be 50% per year, and per half a year it's going to be 25, right? Right? So this bond is going to be promising you $25 here, $25 here, $25 here, $25 here, $25 here, $25 here. So this bond is going to be promising you a semi-annual coupon of $25 for 3 years, right? And of course, at maturity, you're going to be promised the $1,000. At maturity, you are going to be entitled to the $1,000, right? What's interesting here is that once you receive the $25 coupons, you're not going to be cashing them out. Got it? What's interesting here is that once you're going to be receiving the $25 coupons, you're not going to be cashing them out, right? You're going to be reinvesting them. You're going to be what? You're going to be reinvesting them, right? Right? you're going to be letting them debalance over the duration of the bond. You're going to be letting them what? You're going to be letting them debalance over the duration of the bond. So upon receipt of that first coupon, you're going to be reinvesting it for how long? You're going to be reinvesting it for how long? For 5 periods. You're going to be reinvesting it for what? For 5 periods. Because you received it at the end of the first period, and you have 5 more periods to go, and then you're going to be reinvesting it for how long? You're going to be reinvesting it for 5 periods. So you're going to be letting it balance for 5 periods. So this is going to be how much? If you reinvest the $25 for 5 periods at a rate of return of 10% semi-annual.
5.
So how much you're going to be having?
5.
You're going to be having 25 times 1 plus 10% over 2, right? How much is 10% over 2? It's 5%. So it's what? 1 plus 5% is what? Is 1.05. So it's going to be 1.05 to the power of, to the power of 5. To the power of what, To the power of 5, right? Right? What about the second coupon?
And the power of 4.
The same logic. You're going to be reinvesting it for how many periods? For 4 periods. You're going to be letting it balance for how long? For 4 periods. So how much we're going to be having here?
25.
25 times 1.05 to the power of 4. Bravo. What about the third coupon? What about the third coupon?
Say.
You're going to be reinvesting it. You're going to be reinvesting it for how long? For 3 periods to come. So you're going to be having 25 times 1.05 to the power of what? 3. What about that fourth coupon? The same deal. You're going to be having 25 times what? 1.05 to the power of 2. What about the fifth coupon? What about the fifth coupon? You're going to be having 25 times what? Times 1.05 to the power of what? To the power of 1. What about that final coupon? You're going to be having it to the power of 0, which is what? Which is 25. Which is what? Which is 25. So it's going to be like, it is going to be untouched, right? It is going to be untouched. So how much we're going to be having in total at maturity? How much we're going to be having in total at maturity? So in total at maturity, how much we're going to be having? In total at maturity, how much we're going to be having? So how much we're going to be having at maturity in total? How much, Hamad? Alauddin? Multiply and add. Yes, sir. And of course, you have to add the 25 and the 1,000 too, right?
25 and
Of course, you add everybody here. How much you're going to be having at the end of 3 years? How much you're going to be having here? How much you're having here? You got it? How much you're having here? You're having everybody, right? You're having the 25 plus the thousands plus the reinvestments, right? So how much in total?
Okay, from where you get the 1,000?
It's implicit. It goes without saying. So we know that a real world coupon promises $1,000 par value at maturity.
So this is fixed.
Of course, yeah, a real world bond promises this much at maturity. Of course, yeah, of course. Oh, we talked about it before.
From where we get 25?
Here, okay, the 25 is how much? We have 5%. We have 5% annual coupon, right? Semi-annual is going to be what?
10.
10.4.
Semi-annual is going to be 5% over 2.
Okay,
Times what? Times the par value of $1,000. And the answer is going to be what? 25. You got it? So tell me now, how much in total are we going to be having here?
So
How much in total? How much in total?
1,455.
Is it? Do you concur?
1,170.
1170. Good.
1170.04.
$1170. Good. Thank you, Bara. $1170. Now let's go ahead and solve the problem. Let's go ahead and solve the problem. Now, what are we looking for? What are we looking for? We're looking for R. We're looking for what, huh? For R. This is your P0, and this is your F, huh? This is what, exactly, bravo, thank you. This much is gonna be your F3, right? This much is gonna be what, huh? Your F3, right? So given P0, F3, we can go ahead and solve for, huh? We can go ahead and solve for R, right? So give me the setup. So the 1170 is gonna be, this much is gonna be your F3, right? The 1170 is gonna be your F3. And given a P0 of 951.9, we can go ahead and solve for R, right? Now tell me how. Tell me how. How we're gonna be solving for R? Tell me how. Okay. Are we done here, guys? Are we done here?
Yes.
So, okay. So now tell me, P0 is gonna be what? P0 is what in finance?
D.
D. D of what? 1170, right? What is it? Single sum, of course. It's a one-time amount, right? R is missing, right? M is how much for a bond?
2.
M is 2 for a bond, right?
3.
N is what, huh? 3. Let's apply. How much is P0? 951.9. And this is going to be what? Let's discount the 1170. This is going to be 1170 times 1 plus R over 2 to the power of negative 2 times, huh?
3.
Times 3. And so R is going to be how much? And so R is going to be how much? And 50 R is going to and so R is going to be how much? So R is going to be how much, guys? So we can do it. All right. I can do it. So it's going to be it's going to be 2 times 1170 over 951.9 to the power of 1/6, right? Minus 2. This is going to be correct. I did it in a single step, and this is going to be correct. I hope this is correct. Okay. This is correct. Alhamdulillah. This is correct. This is good. So how much is it now? How much is R? How much is R? You can do the math at home, right? How much is R? Bara, any luck?
Be a minus.
No, a minus is not going to do it.
1 by 93.
1.93.
No?
Okay, so
Is 6.
Yes, sir. 6.7%? 7%. It's going to be 7%. Good job. Good answer. It's going to be a 7%, of course. It's going to be a 7%. It's going to be a 7%. 6.9%, which is 7%. Of course, 7%. So I hope this is clear.
and this is it for 0%.
No.
No, I mean not for the 9.
Yeah, that's it. For this problem, that's all. Of course. For this problem, that's all. Now tell me, what should I do next? The 12th problem, right? All right, well, this is about the proof, right? So for that problem, you're going to be watching the equity evaluation video, right? So for that problem, you're going to be watching what, huh? You're going to be watching the equity evaluation video, the proof, right? So watch the video. Make sure you can do the proof. Let's go ahead and do now the 13th problem. Oh. So for the 13th problem, what am I going to be solving for? For the 13th problem, what am I going to be solving for? I'm solving for P0. This is very clear, right? And what am I going to be using here? Gordon growth, right? What am I going to be using, huh? Gordon growth. So given D0, we're going to be solving for D1 and go in Gordon growth, right? So let's go ahead and do it. No problem. Let's go ahead and do it. So how can we do it? How can we do it? So Gordon growth is going to be how much? Gordon growth is going to be how much? Well, Gordon growth is about P0 equals what, huh? Equals D1
Over R minus.
over R
Minus G.
minus G. But how much is D1? It's D0. It's what, huh? D0 times 1 plus G, right? Over R minus G, right? So what's D0? What's D0?
10.
It's 10 times what? Times 1 plus G, which is 1 plus 6%, which is 1.06, right? Over 2%. And the answer, well, 10 over 2%, this is 500. And 6% over 2%, this is a 30. Okay. Well, it's 60% over 2%. This is a 30. That's gonna be 530.
530.
Of course, 530. This is gonna be 530. It's gonna be 530. Okay. It's gonna be 530. I hope this is clear. Huh?
Clear.
Okay. You're done?
Yes, clear.
See here, once I want to show you like some similar problems. See? Common stock paid $1 annual dividend. So D0 is 1, right? P0 is 20. And the growth is going to be how much? 6%. And we're asking here about R. You got it? You got it? So in that particular problem, the 5th problem in the book, you were given P0. You got it? You were given P0. You were given P0, right? You were given D0. You were given G. And therefore you can do what? You can do D1, right? And you were asked to find out about, and you were asked to find out about R. You got it? You see what I'm driving at? Good. All right, let's go ahead and do the 14th problem. Okay, so the 14th problem, what are we going to be having? What we have for the 14th problem, again, we're solving for P0, but instead of D0, what are we provided with? We're provided with D5, right? So we got to go back to D1. How can we do it? You know how? So Gordon growth again, and let's go ahead and do it. So this is going to be what? Again, P0 is what? P0 is D1 over R minus G. But we're not given D1, right? What we have is D5. So we can work back from D5 to D1. How? D1 is going to be D5 times 1 plus G to the power of, Negative 4. Negative 4 over R minus G. Which is going to be how much? How much is D5? How much is D5? 13 point what, 13.38 times 1.06, right? to the power of negative 4 over 2%. And guess what? The answer is going to be still our friend, $530. Okay? The answer is still going to be the $530.
529.9.
Which is 530. Forgive me. Hello, Dean. I know you're a smart man. You got it? All right, let's go ahead and do the last problem.
Ah, so
We're almost done here.
let's remove the last one. Let's just discard it. Yes.
Remove his name from
All right, let's go ahead and do the last problem.
How about that?
Okay, well, let's see. What we have for the last problem? It's an interesting problem. So, have I done it before? Have I done any similar problem? I guess I have. But let's see here. The growth is not constant, right? The growth rate G is not constant. It is 20% for the first 3 years. It is 16% for the next couple of years, and then 7% ever after, right? So G is not constant. So how are we going to be answering to that problem? Whenever G is not constant, we got to be doing it one step at a time. We got to be doing it what, huh? Because we cannot use Gordon growth unless G is constant, right? This is a condition for Gordon growth, right? Now G is not constant. So what are we going to be thinking about here?
Separate?
We're going to be doing it separate. Bravo. Bravo. We're going to be doing it what, huh? We're going to be doing it separate. Let's see how. Let's see how. So first we got to be solving for D1, right? So first we're going to be solving for D1, and D1 is going to be what?
PZ.
D1 is going to be what? D0 times 1 plus G. How much is it now? What's D0?
But you have to drop 10.
How much is D0?
530.
It's D0 is how much?
Oh.
It's 10 times 1 plus G, which is 1.2. And the answer is going to be what? Is going to be what?
But G is higher than R.
No problem, but it is not constant, right? It is not constant. The Gordon growth requires that G is constant and R is constant, and of course R has to be larger than G. But we're not doing Gordon growth now, right? We're not doing Gordon growth yet. You got it? So tell me. So 10 times 1 plus G. The first G is how much? 20%, right? So 1 plus 20% is 1.2. 1.2 times 10 is what? 12, right? D2 is going to be how much? It's going to be 10 times 1.2 to the power of, to the power of 2, right? Which is going to be how much? Which is going to be how much? 10 times 1.2 to the power of 2 is going to be how much? 14.4, I guess. Right? 14.4. Okay, 14.4. What about D3? How much is it? D3, how much is it? 10 times 1.2 to the power of, And this is going to be how much?
17.2.
17.8. 17 point, 28. Thank you. What about D4? What about D4? Well, it's going to be the 17.28. It's going to be what, Because the growth is not going to be the same now. The growth is going to be going down from 20% to 16%. So we're going to be taking the third dividend and multiplying it by the new growth, which is going to be how much? Times what, 1 plus 16%, which is 1.16. And the answer is going to be how much? And the answer is going to be how much? So 1728 times 1.16 is how much?
20.00.
20.
20.
It's going to be 20, no problem. What about D5? D5 is going to be 20 times 1.16, right? Which is what, again? Which is what? Which is 17.28, right? Times 1.16 to the power of 2, which is how much?
23.
Huh?
23.
23. 23.2. What about D6? And we're going to be done. D6 is going to be how much?
23.1.
D6 is going to be how much? 23.2.
Yeah.
Doctor, 1.16, from where we got it?
This is the growth rate.
16%.
16% for the next 2 years.
Okay.
You got it? 16% for the next 2 years. So 23.2 times what? Now the growth rate is not 16% anymore. It's not 20%, it's 7%. So it's going to be 23.2 times 1.07. And the answer is going to be how much? 24 what? 24.86, right? 24.86, I presume.
Yeah. 24.
86 or 87. Okay, no problem. All right. So let's go ahead and now and answer the problem. How are we going to be answering the problem? Let's go ahead and solve for P0. P0 is going to be what?
D1.
Yeah, we have to discount. First, when can we possibly use Gordon growth here? When? We can use Gordon growth whenever G is constant.
Yeah.
And G is constant starting D6, right? So starting D6, G is what? G is constant. So we can do P5 based on Gordon growth. We can do P5 from Gordon growth. Why? Because starting from D6, G is constant. Starting from D6, G is what? G is constant. So we can do P5 based on what? We can do P5 from Gordon growth. Let's see how. P5 is going to be how much?
It's 23.
P5 is going to be how much? It's going to be D6, right? We talked about it last time. I'm not going to be going there again. I don't have time. So P5 equals what?
R.
D6 over? R minus G. Good. So D6 is how much?
It's 24.8.
24.86 over? R. What's R?
It's
8%.
minus
8%.
7.
G now is what? 7%. Right? And now P5 is going to be how much? It's going to be $24.86. It's going to be $24.86.
24.
$86, right? 24.86 over 1%. It's going to be coming down to 24.86. So let's go ahead and solve now for P0. How are we going to be solving for P0? How many things we have to discount? How many things we have to discount? How many things? 1, 2, 3, 4, 5, and and 6. We have 6 amounts to discount. We have what? We have 6 amounts to discount. Let's go ahead and discount them. So P0 is going to be how much now? P0 is going to be how much?
D1.
D1 is going to be how much? D1 is 12 times 1.08, right? To the power of -1, right? Plus D2, which is what? 14.4 times what? 1.08 to the power of
-2.
plus
17. Yeah, 17.28.
17.28 times. Tell me. 1.08
in the power of
to the power of
-3.
plus
17.28.
plus 20. right? Plus 20 times what, huh? 1.08 to the power of, huh?
-4.
Plus
23.
23. 23 point what? 0.2 times 1.08 to the power of, huh? -5. Plus what? Plus P5, which is how much? Which is 2486 times what? Times 1.08 to the power of, huh? To the power of -5. It's P5. It's P5, and therefore it has to be discounted 5 years. And the answer is going to be how much?
5 minus 5.
Of course, yeah. Of course. The answer is going to be how much?
هذه خليها homework.
But why we put for B5 here, not D5, not D6?
D6 is not going to be here because we use D6 in order to compute P5.
I mean, why we multiply
D6 here, I use D6 in order to get P5. Right? But once I have P5, I don't need D6 anymore.
But we should multiply B5 by R.
Of course, because P5 is a promised benefit. You're entitled to P5 after 5 years, right? You're going to be entitled to P5 after 5 years.
So, but the difference here is we put the power is negative.
So this is as if you're going to be purchasing the share now. You're going to be purchasing the share now, staying in the share for 5 years, right? Staying in the share for 5 years. And then what are you going to be entitled to? You're going to be entitled to the price after 5 years and all the dividends in between. You got it? You got it?
Yeah.
So you purchased now for P0, and you're going to be cashing out 5 years from now for P5.
Yeah.
And in addition to B5, you're going to be entitled to all the dividends in between. The answer is going to be how much, Ahmed?
خلصنا يا عماد.
1759.
$1,760.
Yes.
Thank you so much. Thank you so much. We'll see you next time.